Welcome to the Rate of Change quiz review video. You're welcome. So you want to be able to find the slope of a line given 2 points. So let's say you have the points -3, 6 and the point 5, 10. Remember that slope is change in y over change in x. So you can go ahead and label your points. This can be, let's use a different color. This can be x1, y1, and x2, y2. So y2 minus y1 would be 10 minus 6 over x2. Did I say y2 or x2? I don't really know. But no, 10 minus 6 is y2 minus y1, and 5 minus -3 is x2 minus x1. So 10 minus 6 is 4 over 5 minus -3, which is 8. That can be simplified to 1 over 2. You should also be able to find the slope of a line by looking at a graph. So say you're given this graph, still change in y over change in x, but one of the easier ways to think about it is rise over run. So your rise is going to be your y. So going from one point to another point, how much do you go up to get on the same level as that point? And that's going to be, you go up 2 units. So your rise is going to be 2. And then your run is how much do you go over to get to that point. And that's going to be run 5. And so you can also see whether it's going to be a positive or negative slope by looking at the line. Okay, going from left to right, you would be going uphill. So your slope is going to be a positive 2 over 5. So here's another example. You're given a graph and you want to find the slope. Ask yourself, so rise over run. Okay, to get from one point to the next point, you have to rise 2, run 3. Rise 2, run 3. So your rise is 2, your run is 3. But when you look at this graph going from left to right, you'll be going downhill. So remember, that's a nice negative. So next is an example, a word problem for average rate of change. You're also going to see this on your quiz. So Kevin's savings account balance changed from $1,140 in January to $1,450 in April, and wants to know the average rate of change per month and round to the nearest dollar. So I would make a table. In January it was $1,140. Something happened in February. We're not really sure. January, February, March, and April. And we know in April it was $1,450. Okay, so we're talking about, time, really, number of months, and amount, I guess you could say. So because rate of change, we talk about changing dependent over independent, we're going to do the change in amount over the change in time. So changing your amount is going to be the $1,450 minus $1,140. And then in time, okay, it might help you. Be careful here because January, February, March, April, there's 4 months there. But be careful. Let's label this. Let's say we label this January as 0, 1, 2, 3. All right. Then from April to January, we would do 3 minus 0, which is 3 years. So 1,450 minus 1,140 is $310 over $310. Make sure we include our units. And that was saved in 3. I don't know why I said years. That was saved in 3 months. So if I were to simplify that, I would divide, and it'd be about $103, $104 dollars per month. So that would be your average rate of change. So do you guys want to look at another example?
Yeah!
I'm really glad you're excited about this next example. Alright, so a scuba diver is 30 feet below the surface of the water 10 seconds after he entered the water, and 100 feet below the surface after 40 seconds. What is the scuba diver's rate of change? So once again, you can kind of do your table, or, well, I guess you don't really have to do a table here, but you do have to identify your independent and dependent variable. So your independent variable, I-N-D-E-P-E-N-D-E-N-T. Okay, your independent variable here is going to be time in seconds. And your dependent variable is going to be feet below the surface. So you can do change in feet below the surface over change in time. So feet below the surface was, remember, here it doesn't matter what you put first as long as you're consistent, but I like positive things. If I start with positive things, so I know the 100 feet is greater. So I'm going to do 100 minus 30 for my change in surface, or feet below the surface. So that means I have to think about what time corresponds with 100. And it says he was 100 feet below the surface after 40 seconds. So 40 is going to go with the 100. And then 30 feet below the surface after 10 seconds. So 10 seconds is going to go with the 30. And then I just simplify from there. Make sure we add our units afterwards. So 100 minus 30 is 70 feet over 40 minus 10, which is 30 seconds. Once you actually divide and simplify that, you get about 2.3 feet per second. Okay, and the very last thing, remember that if you have a graph and it's increasing like this, remember that the slope's going to be positive. That if you have something like this, I don't know why I did the graph like that, but something like this where it's decreasing, your slope's going to be negative. And if you have a graph where you have a vertical line, remember that means it's undefined. And last, if you have a horizontal line, regardless of where it is, where it's placed, that means your slope is 0.